Hello students, this is the 7th video, believe it or not, in Unit 4, the Transformations Unit. You've already learned about all the different types of transformations, about translations, about rotations, about reflections, those are the three rigid motions, and also about dilations, which is the motion that allows you to change the size of the shape. Now we're going to do compositions of transformations. In other words, we're going to be combining transformations together. To one shape, we might flip it over, do a reflection, and then translate it down, do a slide. Or we could slide it first and then do a reflection. There's a lot of different combinations that we could do. Let's take a look at the learning target. In this learning target, it says we can identify compositions of transformations. Keep in mind, a composition is just two or more transformations. Typically, in this class, we'll only be dealing with two, without a coordinate plane. So we're not going to be looking at specific x, y coordinates. We're not going to have to worry about what happens specifically to the numbers. All your job is to identify transformations that are shown to you. And also, if I give you a shape, describe what the shape would look like after two or more transformations. And write using transformation notation. You remember the notations for the four different transformations are capital T translation, capital D dilation, uppercase R for rotation, and lowercase r for reflection. Let's take a look at the do now. In the diagram, it gives us congruent figures. Congruent, that means the same measures, right? 1, 2, and 3 are drawn. We have to figure out a sequence of transformations. Now, whenever it says sequence of transformations, it's also talking about composition. Sequence and composition mean the same thing. And one other thing that it tells us to do is go in order. We're going from figure 1 to figure 2, and then from figure 2 to figure 3. So we're going in order, 1, 2, and 3. Pause the video, try it out, and then see if you got it right. Okay, before I show you the answer, there's one thing I want to point out to you. It says that figure 1 is A, B, C, D, E, F, right? Figure 1, A, B, C, D, E, F. Now notice that figure 2 is A prime, B prime, C prime, D prime, E prime, F prime. All of these points have been transformed once, so they all have a prime. Notice that figure 3 has A and then two little lines here. We call these double primes, right? So this is the regular shape, the pre-image. This is the image, and this is another image. This is the prime version of the image, and this is the double prime version of the image. That double prime just means two different transformations. So that just helps you visualize what's going on. All right, now for real. Pause the video and try to figure this out. All right, the first thing that you should see is that we took figure 1 and we slid it up and to the right. We translate it along a vector. We don't know exactly how much we went to the right, and we don't know exactly how much we went up because there's no coordinates here, but that's okay. We're able to identify that vector by any pair of points. So for example, I'm going from A to A prime. Notice that that same vector is the vector that's down here from E to E prime. I can identify using any one or any two of those points. So I'm just going to call this vector A to A prime. All right, so that was the first transformation. Now looking from figure 2 to figure 3, here's that next transformation. And you can see from shape 2 or figure 2 to figure 3, what we did was we spun the figure around the origin by 270 degrees. Remember the old trick. We take any two points, let's say D prime and D double prime, and connect them back to that center of rotation. Notice that it makes a 270 degree rotation around there. Why didn't I say 90 degrees? Because that would be clockwise, and we always use counterclockwise when we define our rotations. Okay, so we have two different transformations here, a translation along a vector and a rotation of 270 degrees around the origin. Now you might think to yourself, well, I'll list them in that order. Well, keep watching because there's a couple of different things that I got to tell you about. All right, taking a look at compositions of transformations. At present, at this first exercise, we can see triangle ABC is where it is. It's in the first quadrant. It's pointing upwards. You can see that the next thing, or the next figure is A prime, B prime, C prime. Looks like it's been rotated around so that it is now in the second quadrant. And then last but not least, it goes from A prime, B prime, C prime down to A double prime, B double prime, C double prime. And it looks like it's been flipped over that x-axis. A and A prime are the same distance away. C and C prime are the same distance. B and B prime, or I'm sorry, I should say B prime and B double prime are the same distance from that x-axis. So we can write down the order like this. All right, so what I've done here is I've written them out in words. Here's triangle ABC, which was rotated around the origin by 90 degrees, and here's A prime, B prime, C prime, which was reflected across the x-axis. And I've listed out the two transformations here. Now what I'm going to do is write them out in transformation notation. And you should remember that capital R 90 indicates a rotation by 90, and lowercase r x-axis means a reflection across the x-axis. Now I have to combine both of these into the composition of transformations, and here's how it's supposed to look. All right, take a second to take this in. Notice that the first transformation that's supposed to happen is rotating around the origin 90 degrees. The second one that's supposed to happen is reflecting across the x-axis. But the way that we write it out is like this. This is called composition of transformations notation, or simply transformations notation. Why do we write it like this? It's very simple. The order of operations goes like this. I'm looking at the original shape here, which is called the pre-image, and I'm going to apply the transformations to this pre-image in order based on what's closest to the pre-image. So for example, here's triangle ABC. I'm going to first take care of the rotation of 90 degrees, then I'm going to take care of the reflection across the x-axis. It goes in order between what's closest to the pre-image. So to the pre-image, we apply the first step, and then we apply the second step. This is just a little circle. I don't know what this symbol is called. Hold on, let me look this up real quick. All right, I looked it up. The best I could find was that this is a composition symbol. Anyway, it just tells us to a specific shape, I'm going to apply with this transformation, then I'm going to apply this transformation. All right, let's take a look at the model problem. This kind of looks like home plate. Identify which sequence of transformations could map pentagon ABCDE, which is this one, onto pentagon A double prime, B double prime, C double prime, D double prime, E double prime as shown below. So what we have to do is name the transformations that brought this onto this. There's a couple of different options here. I'm going to show you two of them. Pause the video and try this one out, and then I will show you my answers. All right, there's one possible sequence of transformations. First, a translation from E to E prime. I'll draw that in now. Remember, translation is just a slide, so I could take this shape and slide it along this vector, so now it's here. And now you can see that the shape is sort of lined up with the new shape. All we have to do is reflect it across the line AE. So if I reflect it across, here's how it would look. I would just have to use the flip tool here to flip it down, and it would flip onto the shape. All right, so what we've done is we have identified two different transformations that could bring pentagon ABCDE onto A double prime, B double prime, C double prime, D double prime, E double prime. Now that we've written it out like this, let's write it in composition of transformation notation. So in transformation notation, being really specific is saying a reflection across AE happening after a translation across or along the vector E prime. So that is a very specific way to say it. Most of the time on the quizzes or tests or on the Regents exam, it will ask you what the actual transformations are, but it won't ask you to be super specific with what you're transforming them around, like what the axis of reflection is or what the center of rotation is. All it's going to be asking you to do is what the composition is. There's another way to get from this pentagon to this pentagon, and I'll show it to you now. All right, in this second possible orientation of compositions of transformations, we could rotate it around 180 degrees around a point. I'm going to call that point point P. It doesn't have to be named though. I'm just identifying that it's rotating it around a certain point. If I were to rotate this shape around that point 180 degrees, it would look like this. That's shrinking. Let's rotate it like that and bring it down here. So that would have been rotating around 180 degrees around that point. And you can see my illustration here that I've rotated it around there. Next, we can reflect it across a vertical line. Notice that we didn't name the vertical line. Just like we didn't name this point, the vertical line could look like this. And if we reflect this shape, let's bump it up just a little bit. If we reflect this shape across that line, it would then become A double prime, B double prime, C double prime, D double prime, and E double prime. Here's how you write it out in words. Now let's write it out in transformation notation. And since we don't know exactly what that line is there, we'll just say it's a reflection, and the rotation is also there. It's 180 degrees. We didn't say around what point because, again, we're not quite sure what that point is. But again, the thing that we're looking for is to write down a sequence of transformations, a composition of transformations that is in the correct order, this one first, this one second, and being able to transform one shape into the other shape. One thing that you should notice is that both of these transformations have something in common. They both have a reflection in them, right? Both of them have that reflection as one of their steps. I know that there has to be a reflection in between these two shapes because of one aspect of those shapes, and that aspect is Orientation. You should remember that orientation is the order of the points around the shape. So for example, if I start here at A and I say I'm naming this shape ABCDE, I'm going from A to B, then from B to C, then from C to D, then from D to E. I've gone around this shape in a clockwise direction. So we say that the original shape, the pre-image, has clockwise orientation. The image, what happens after these two transformations, notice that that image may not have the same type of orientation. Well, let's figure it out. I'm going from A double prime to B double prime, then to C double prime, then to D double prime, then to E double prime. This orientation is the opposite direction. We call this counterclockwise orientation. Since these two shapes, the pre-image and the image, have different orientations, at some point in this composition of transformations, there must be a reflection. That's a good rule of thumb to keep in mind. If the orientation changes from the original pre-image to the new, the image, then there must be a reflection somewhere in your composition. All right, I would move on to the check for understanding, but however, I can't do it because we're going to be doing that in class. So that means this is the end of the video. This was the video on the 7th lesson in Unit 4. This was about compositions of transformations, putting together transformations to get from one shape to another and then to another. All right, folks, good luck studying.